standard deviation can be seen in many different places, but one of the most typical places we use standard deviation in is normal distribution. See, for many, many years, teachers used to grade on the normal curve. So the idea of the normal curve is, if this is the entire class, let's say this underneath this curve was the entire class, a big portion of the class would be right in here. They would be getting C's. Then you'd have some getting B's, and you'd have just a few getting A's. You'd have some getting D's, and you'd have a few getting F's. No matter what, that's how it was working. That's why they call C average, because saying, you know what, majority of the students are going to have a C, and then you can work your way up. You're going to always have A's, and you're going to always have F's. Now, that's not really fair if you consider that, you know, classes are very diverse, and so an A in one class might not be the same as A in another year's class, and so that's where we start coming out with our cutoffs of, you know, 90, 80, 70, 60. But this is what a normal curve is. Okay, so under the curve, we consider all of this to be 100% of students. And when you have a normal distribution, it's kind of that idea that there's a huge amount that are in the middle. You know, we can look at height being this way. There's a huge amount that are in the 5'5" to 5'10" range, right? And then you got some that are taller, and then you got some gigantors that are huge and tall. Okay, then you have some shorter people, you know, in the fives, and then you have some really short people. And so, you know, most people, though, are in the middle, and that's why it's taller in the middle, because if you think about it, it's kind of like a bar graph, okay? So we've got a whole lot in this section. Let's say this is 5'8", okay? And then we've got a whole lot still in the 5'9", and we've got a whole lot in the 5'7", okay? But if we're out here and we're talking about, let's say, 6'6", okay, there's not a whole lot there. It's a short bar because there's very few people there. Okay, so this is a normal distribution. Now, if we look at a normal distribution in general, okay, so 100% of the data is underneath. If we look, the average is actually right smack dab in the middle. Okay, now, remember we just talked about standard deviation. That's how the average distance from the average. And so if we take the mean and we add one standard deviation to it, so let's just say that the average is, let's say, 10, and the standard deviation is 2. So this number right here would be 10, and this number right here would be 12. And let's say that we take one away, so we take the standard deviation minus, or sorry, the average minus is one standard deviation, so then we're at 8. Okay? We are saying that right here, one standard deviation and one standard deviation to the right, 68% of the data fits within that standard deviation. 68%. Okay? So that's a huge amount of people or things or whatever data you're looking at that fit within one standard deviation on either side of the mean. And then we keep on going. We say, let's add another standard deviation. Let's take the average plus 2 standard deviations, add it, and let's take an average minus 2 standard deviations. So it's one more standard deviation away, okay? And then this now, this from here to here, okay, so this distance right here is 95% of the data. 95% of the people or data or whatever will fit within 2 standard deviations. That's an amazing amount. If you have a normal distribution, this will be true. Okay, then we go one more, and that's as far as we'll go, but we have standard deviation plus 3, or mean minus 3 standard deviations. So if we continue these numbers, by the way, this would have been 14 and this would have been 6. If we continue that on, now we've got 16 and we've got 4. Okay, from 3 standard deviations away, so from 4 to 16, all of this will be 99.7% of the data. Virtually everything will fit within 3 standard deviations. Now, of course, we have these little tails out here where there's 0.3%. You know, the really extreme ones will be way out there. But within 3 standard deviations, we have 99.7%. Okay? Now, we could also start figuring out what each of these little sections are. Okay? So if this is 68, all the way out to 95. So we take 95 minus 68. Okay. So by doing 2 standard deviations away, we've added 27%. So these two right here add up to 27%. If I divide them in half, I get 13.5. So this little section from here to here is 13.5%. And this little section here is 13.5%. So we're going to work on this in class doing problems where we figure out what percent is from 10 to 14. Okay, and so you want to figure out that percent. Now here we have 13.5, half of 68 is 34. So from 10 to 14, we'd have 38 plus 34, sorry, plus 13.5. That gets us 47.5% of the data is from 10 to 14. Okay, so you can figure out all kinds of percents in here. You can figure out, this is 0.15%. Each one separately is 0.15% because it's 0.03. Did I lie? No, it's 0.3 together. So then separate, you split them in half, you get 0.15%. Okay, so there's all kinds of percents we can work on here. You may want to watch this more than once just so that you really retain what's going on so that when we're working on this in class, you're ready to go.